As promised, not too much this week because you have a test on Tuesday. Okay, so we're going to look at one application of matrices, which is to solving linear systems, which is just a fancy word for simultaneous equations. So for example, in electrical circuits like this one here, where the currents I1, I2 and I3 are unknown, you can write down laws of Kirchhoff and Ohm, and you can end up with these simultaneous equations. And then the question is, well, how do you solve these simultaneous equations? Now, there are better methods than using matrix inverses. I'll be brutally honest with you. Using matrix inverses, but we won't kind of delve into that. I could talk about that for 10 minutes, but let me just say that really what I'm interested in is not actually so much that you know that you can use matrices to solve simultaneous equations, but that you know what a matrix inverse does, that you understand what a matrix inverse does. So this linear system here can be written as this matrix equation. Let us just maybe multiply this out here, and just to show that this is indeed the same thing as above. So if we were to multiply this thing out, let's look at the size of this. It's 3 by 3. Forget my colors. And then 3 by 1. And the middle numbers match. So we're going to get out a 3 by 1. 3 rows, 1 column. And as we should, because this thing is like that as well. So 3 rows, 1 column. Let's cell it up. Now we go through each and we say what row is it, what column, and multiply the row in the first matrix by the column in the second matrix. So the very top of these cells is row 1, column 1. So I multiply row 1 by column 1. And I get 76 by I1. I get minus 25 by I2. Could have given myself more space. Minus 50 I3. The next one is row 2, column 1. So I multiply row 2 by column 1. 25 I1 minus 56 I2 plus 1 I3. And the last one then is row 3, column 1. So I multiply row 3 by column 1. 50 I1 plus I2 minus 106 I3. And this is supposed to equal 10, 0, 0. So that's two vectors that are supposed to be equal, and vectors are only equal when every component is equal. So the first component, the 76i minus 25i2 minus 50i3 is equal to 10 is equation 1. That the second component is equal to 0 is the second equation. That the third component is equal to 0 is the third equation. So you can rewrite these things as matrix equations. Now what I notice is it says multiply this out, but sure we've already done this, so we'll do something else. So if I write this A as the matrix of coefficients, X the vector of unknowns, and B the vector of constants, and what we'll do is we'll solve this equation down here. So what you're looking for here is the vector of unknowns. So what you want to do is get rid of this A. So the question is, how do you get rid of this A? You multiply by A inverse. Now you can't multiply by A inverse on the right here. You have to multiply on the left. And if you multiply by A inverse on the left on both sides, you're doing the same thing to both sides. And if originally you've got two vectors that are equal and you do the same thing to both of them, they'll still be equal. So let me kind of write this down like this. So I'm going to multiply both sides by A inverse on the left. So you get A inverse times AX equal to A inverse times B. So that's A inverse times AX equal to A inverse times B. And A inverse undoes the action of A. So we get that the vector of unknowns is equal to A inverse B. So if you want to solve the the simultaneous equation, what you have to do is find the inverse of that 3 by 3 matrix A. Now we have already spoken about the inverse of a 2 by 2. We're not actually going to ask you to find the inverse of a 3 by 3. Okay. So this is the algebraic picture, and all we need to do is this. And linear system is just a fancy name for simultaneous equations. Now we're going to kind of understand this dynamically. We can describe this kind of geometrically. So look at this 2 by 2 system. So we have a vector 1 minus 4. 1 minus 4. That's the point down here. Now we won't bother drawing an arrow. So you have the point 1 minus 4. And the question is, you can phrase it like this. Which point, or which vector slash point, does the matrix A send to B? So let this be vector x. And the question, so the question geometrically says, what point x does the matrix A send to 1 minus 4? So this is, you can only multiply this vector on the left, so it's okay to write multiplied by A. Right. So, well, how could you do that? Well, if you multiplied the point 1 minus 4 by A inverse, remember, will undo the action of multiplying by A. So you find that x is equal to A inverse times B. So we would have done that on the previous page algebraically. Here's a kind of picture of the algebra, as it were. Okay, so I think we're just going to do some examples. So consider as shown the joint under three forces of magnitude F1, F2, and 10. So the magnitudes, two of the magnitudes F1 and F2 are unknown. Alpha is approximately 22.6, beta is approximately 36.9. Now there's a thing here where like, do you need to use that? You don't, but I'm just trying to make the numbers on the next page work out. So if alpha has an angle inverse tan of 3/4, which is what we said. So they're just the numbers really that make these equations work, basically. So you can show, it can be shown, and you don't have to do that the forces F1 and F2 satisfy these simultaneous equations, or this linear system. So what are the questions? Write this linear system as a matrix equation, hence use the matrix inverse method only to solve F1 and F2. You know how to solve simultaneous equations, but here I'm not really interested in solving simultaneous equations. I'm interested in you understanding what the matrix inverse does. So you have to use inverse matrices. If you don't, you're not really getting any marks. Okay, so we take coefficients and the constants and we write it in this form. So the coefficients are 39 F1 minus 60 F2, 52 F1 minus 25 F2. So the coefficients are the numbers that multiply the variables. And you put them all in the matrix like this. That's the matrix of coefficients. Then the vector of unknowns is F1 and F2. And then finally the vector of constants 0 and 650. So that's A. I could call this F. Well, that wouldn't be a great idea. There's possible confusions. I'm just going to call it X equal to B. So you multiply both sides on the left by A inverse. So you get, now actually you can only really multiply by A inverse on the left here. On the right actually doesn't make sense. So if you put it B by A inverse, actually undefined. Let me just look at that. So B by A inverse. B is a 2 by 1 and A inverse is a 2 by 2, and the middle numbers do not match. So this is actually undefined. So I actually can just, if I say multiply by A inverse, there's actually only one way of doing it in this case. So I don't have to make such a big deal. Now what you definitely can't do is you can't put the A inverse in there. There's nothing that says you can take a matrix and a vector and put a matrix in the middle. No, you either multiply by A inverse on the left or on the right. And here I'm saying you can only multiply by A inverse on the left, so that's your only choice. So we have A inverse, about to multiply both sides. So I get A x here equal to A inverse B, and then the A inverse undoes the action of A, and so you're just left with x is equal to A inverse B. Okay, so we must find the inverse of A. We'll use the formula that, well, it's in the tables, but of course your exam is open book. So the formula says that if you have a matrix A, B, C, D, if you want to find the inverse, you do 1 over the determinant, which is right down diagonal minus left down diagonal, a by d, that's your right down diagonal, minus b by c, that's your left down diagonal. Swap the right down diagonal, so it becomes d and a, and change the sign on the other diagonal, so it becomes minus b and minus c. So therefore, we can find a inverse. So a is up here. So it'll be 1 over, so AD, the right down diagonal, 39 by minus 25. Take away the left down diagonal. Careful with the signs here. Minus 60 times 52. We'll worry about that number a little later. And then swap the right down diagonal. So we're going to swap the A and the D, the 39 and the minus 25. And we're going to change the sign on the other diagonal. So minus 60, 60, 52, minus 52. Okay, I'll probably tidy up the fraction on the front of that. So now just multiply. So what I mean by is x, the vector x, this is just in the line beforehand, is equal to A inverse B. And so I'm going to tidy up this fraction on the bottom. So I get 39 by minus 25, minus plus 60 by 52. I get 1 over 2145. And we still have minus 25, 60, minus 52, 39 times the constants, which are 0 and 650. The 0 is helpful. So we're going to multiply these out. We should look at the sizes. So I see a 2 by 2, 2 rows, 2 columns, and this one has 2 rows, 1 column. The middle numbers match. So I can multiply these together. So I get 1 over 2145. The middle numbers match, so I'm going to get out a 2 rows, 1 column. Now I wonder, like, does it say anything about the rounding? 3 significant figures. So our answers will be rounded to 3 significant figures. Okay, so we've got this thing. It's got, with the top of it is row 1, column 1. So I'm going to multiply row 1 by column 1. So minus 25 by 0 is 0, and then 60 by 650, I get 39,000. And now I have row 2, column 1. So I multiply row 2 by column 1. Minus 52 by 0 gives me 0, and then 39 by 650 gives me 25350. Now I should divide them by 2145, so I'm just going to write approximately, because I'm rounding, so I multiply both of them by 1 over 2145. This number is a fraction, and when you multiply a vector by a number, it is just a number after all. You multiply both of them. So the thing inside this thing is a vector. It's not a fraction. This is a fraction. So basically what you have is a number by a vector. And when you have that, everything in the vector gets multiplied by the number. So I have 39,000 multiplied by 1 over 2145. 3 significant figures, I get 18.2. And then the other one is 25350 by 1 over 2145. And I'm getting out 11.8. Now we can check our answer. So this is F1 and the other one is F2. That's clear from up here with a substitution. So we can check our answer. Now there will be some rounding because we rounded, but they shouldn't be far off. So 39 F1 minus 60 F2. So this is approximately, so I'm going to 39, I'm substituting in these numbers into this, okay. So I get 39 by 18.2 minus 60 by 11.8, and so this comes out to like 1.8. Now you might say, oh, that's not approximately 0, but it's close enough. What you could do is don't round and put them in like that instead. I'm not going to go back and do that. If you look at, say, 60 by 0.05, I'll just explain this. So, say, or even 39 by 0.05. So in rounding the 18.2, we could have been out by up to 0.05. And now that difference is going to be magnified because we're multiplying the number by 39. So 18.2 could be up to 0.05 away from what it should be. If I multiply it by 39, I'm getting 1.95. Okay, and that's where that's why the number here is a little bit off. Okay, so yeah, it probably would make more sense to take the pre-rounded fractions. There were fractions, I never wrote them down here, and check with those. And we'll check the other one as well. Like if they're miles off, you know, they should be miles off. This one could be off by a bit. Well, we'll see. So the other one is 52 F1 minus 25. Yeah, so this one shouldn't be like, this one kind of should be out by about 2 as well. But because you're going for 650, it should be very close. So you're looking at between 648 and 652. Yeah, it just would have been easier just to put in the fractions. Another reason, I suppose, that why mathematicians prefer exact numbers. So this comes out as 651.4, which is approximately 650. So yeah, if you want it, yeah, it probably just makes more sense to get the exact answers if you want to check your answer. All right, so that's that one. Next question. A mathematics exam worth 245 points contains 45 questions. Some questions are worth 7 and the others are worth 2. I want to find the number of questions that are worth 7 points and the number of questions that are worth 2 points. Now, what this means is that these are the unknowns. The number of questions that are worth 7 points and the number of questions that are worth 2 points. They are our two unknowns here. Okay, so clearly defined, they're the two unknowns. Now, if you say x or whatever is the 7 points, that's not really maths. X is 7 points, or even x is 7 points questions. X should be a number. So x is the number of 7-point questions. Maybe y is the number of 2-point questions. Write down the linear system. So what we're going to have to do is we're going to have to write down simultaneous equations and then use the inverse matrix method. So let's see how we get on. Okay, so with two unknowns we can name by everyone. How about x and y? So let x be the number of 7-point questions and y be the number of 2-point questions. Right, so the first condition says that the number, so there's 45 questions. So the number of 7-point questions plus the number of 2-point questions must equal 45. So that's where we're getting this x plus y is equal to 45. Now the second one is an equation in the points. It's saying that the total number of points is equal to 245. Now this is an example of something that I actually think students should find difficult, but they don't. So it's about how many points. So we'll say, so I'm going to write points 7 plus points 2. Now you don't have to write this down. I mean, if you just get to here, I'm quite happy, is equal to 245. So the points 7 is the number of points in the 7-point questions plus the number of points in the 2-point questions. So altogether that will make up the 245 points. So how I do this is I kind of go, oh, if there's 0 7-point questions, points 7 is 0. If there's 1 7-point question, 0.7 is 7. If there's 2 of them, it'll be 14. If there's 3 7-point questions, it'll be 21. 4 will be 7 by 4. 5 will be 7 by 5. But if there's x 7-point questions, there'll be 7x points from the 7-point questions. So how many 7-point questions are there? X. multiply that by 7 to get the total number of points from the 7-point questions. And similarly, we have 2 times y is the number of points from the 2-point questions, and you equal 245. It's very likely that I made that harder than it sounded. It's just one of those weird things that students seem to find okay. They just write it down, but to me, it's actually a bit harder. And if you can get these two equations, then you're fine. Okay, so the second thing I think is to solve it using the inverse matrix method. So we write it as a matrix equation. So now what's the multiple of x here? Well, it's just 1, and here's just 1. So you have 1x, 1y, 7x, 2y times xy. Now I'm using square brackets. There's no difference between square and round brackets. There's no meaning whatsoever. And if I write this as ax equal to b, and if I multiply both sides on the left by a inverse, so I get a inverse times ax equal to a inverse times b, and the a inverse times a, well, the a inverse this is on the left hand side here, I'm looking at that undoes the action of multiplying by a, so I just have x is equal to a inverse times b. Okay, so all I have to do here really is find a inverse. Now I'm going to use the formula in the table, so you should probably try this yourself. I'm just going to do it kind of quicker here. 1172 inverse. So the formula says you do 1 over AD minus BC. If you want, you can label them. I don't think it's really necessary, but you can. This would be A, B, C, D. And you do 1 over AD minus BC, which is 1 over right down diagonal minus left down diagonal. That's 1 over 1 by 2, so that's 2, minus 1 by 7 is 7. And then the formula says you swap the things in the right down diagonal. So instead of 1 and 2, it's 2 and 1. Because the formula says dA, so instead of AD, it's dA. And then it says change the sign on the other diagonal, because it says minus B and minus C. So this should be minus 1, this should be minus 7. So we get 1 over minus 5, 2 minus 1 minus 7, 1. Okay, so now all we have to do is to find x is we're going to multiply a inverse times b, and b is above. So x, which is the unknowns x and y, probably better off, should have used b, so let's write that up here. Would v already there, you see the confusion, there's x, there's the number x and the vector x, be better notation. The answer, in my opinion, is yes, but we're too far gone. I won't go back and change them. So anyway, x is a inverse times b. A inverse we have is 1 over minus 5, and then the matrix is 2 minus 1 minus 7, 1, times the vector of constants, which is 45, 2, 4, 5. And of course here I would have spoken in the vectors tutorial Zoom. I was saying that you should check does your answer make sense. Now here x and y are numbers of questions, so if your answer isn't a whole number, you know that you've gone wrong. Okay, let's multiply these together. So this is a 2 by 2, this is a 2 by 1. We can multiply these together because the middle numbers match. And we're going to get out a 2 by 1, and the minus 1/5 can just sit there at the moment. I'm just going to keep it as 1 over minus 5. It is the same as minus 1/5. So you get out 2 rows, 1 column. Okay, so we go through and we do row 1, column 1, row 2, column 1. So just in case you've done, if your brain is fried, say the first one here, this one is going to be row 1 by column 1, and multiplied like at that product. So as in 2 by 45, oh, that won't work. as in 2 by 45 minus 1 by 245. And the next one is row 2 minus 7 by 45 plus 1 by 245. And now we're going to multiply these in. So I need to multiply in the 1 over minus 45. So I have 2 by 45 minus 245 multiplied by minus 1/5. And I'm getting 31. And then the other one, I'll multiply in, but it should be possible actually just to take the answer, because you know that it has to be 14 because they have to add up to 45, but sure, we'll do it anyway. Minus 7 by 45 plus 245, yeah, 14. So the answer makes sense in the sense that the answers are whole numbers. So let's check our answers. So x plus y is equal to 31 plus 14 is 45 tick. And the other one is that the 7x plus 2y, so that would be 7 by 31 plus 2 by 14 should and equal 245, correct. So you can check your answer with these, but I'm mostly interested in that you know what the inverse of a matrix is. Now we'll keep it as short as that this week because you have your test, but in week 6 obviously it could go to 3.5 hours, but I think that helps you overall.